want to thank y'all for coming out for this program today. What Dominion wants to do, they want people to be safe around power lines. A lot of times when we have a major storm or something, we're not going to be the first ones to get there. Y'all may get there before us. So we want y'all to be safe around power lines, get a feel for what's going on with them, and some of the parameters you should stay away from them. What we have here, it's an ARC demo trailer, and what this does, it takes low voltage, feeds it through the transformer and creates high voltage. This morning we were having about 7,000 volts. And what we're going to do, we're going to show you some arcs, we're going to blow some fuses, and just show you what type of energy is in that power line and how dangerous it could be. The arcs we're going to do today are very small arcs because they are starting from 0 amps. Okay, out there on our power lines, we have existing amperage on the power lines. So this is going to be a very small arc compared to what would happen on our lines if we made a mistake and made an arc out there. Out there, you'd get a big ball of fire and a concussion. If we had 100 amps on our line, what you see today, you would have to multiply it by 100, and that's what we would be dealing with if we made a mistake out on the power lines. The first thing we want to show you is what type of voltage we're going to be dealing with today. All right, we've got about 7,200 volts on this line. And just to let you know, this would be considered a very low voltage on our system. On our system, the majority of our lines, 70% of them are 19,900 volts phase to ground, 34,500 volts phase to phase. So if we were working on this, this would be considered a lower voltage that we would work on. And the first thing we're going to do today, we're going to draw some arcs. So, like I said, this would be considered a little arc for us, but at least it'll give you an idea of what an arc sounds like, what an arc looks like. And this is something that we try to avoid, having an arc while we're working. The next thing we're going to do, we're going to cook a hot dog real quick. Like I told you, this arc is around 11,000 degrees. If you melt steel at about 3,500 degrees. But this is around 11,000 degrees. We use a hot dog because it's the closest thing we can get to like the human body. It's got meat, it's got fat, and it's got moisture in it. And this thing's going to cook very quickly. So we're going to go ahead and show you what would happen if you contacted a power line. The next thing we're going to talk about, linemen have to use personal protective equipment. And one of the things we have to use are rubber gloves. Another thing we use, all of our clothes is Nomex, and it's fire retardant. This particular guy had a bad day at work. He made a short, but the Nomex saved him from getting burnt real bad. He had a big flash, a big ball of light come on him, and he didn't get severely burned because he had Nomex on. We all have to wear hard hats, and our hard hats are rated for voltage also. We have to wear steel-toed gloves. Whenever we work, we have to have glasses on to protect your eyes. But one of the main things we use rubber gloves and sleeves. The rubber sleeves are there just for accidental contact. The only thing we can touch high voltage wires with are rubber gloves. And every day before linemen use their gloves, they have to air test them. They fill them up with air and they put it up by their cheek, and they're listening to see if any air is escaping or trying to feel any of the air coming out on them. Our rubber gloves are two different colors. They're red on the inside and they're black on the outside. 80% of it is red, 20% of it is black. So when we roll it up to look at it, we're looking to see if any of the red is showing through. If any red is showing through, we know we've got to get rid of that pair of gloves. We know they're no good anymore. So I know we passed out a few gloves. You need to put them on your hands and see what it feels like to be a lineman for a while. They're very hot, very uncomfortable to work with. What I'm going to do right now, I'm going to take this needle and I'm going to put one pinhole in this glove. And if a lineman, we work with a lot of splinters, a lot of nuts and bolts and sharp stuff. If we have one hole in our glove, it's probably going to equal a fatality. And we'll show you what happens if we did not do a good job. He may have to rub it around a little bit to find that little hole I put in it. But you'll see how this glove can fail with just one tiny prick hole in it. That right there would be a fatality, somebody on our system. Everything we use, our sticks, the stick Jonathan's using right here, the stick is tested at 100,000 volts per foot. It has to be clean. If it gets dirty or we lay it on the ground, we have to clean it and retest it. So everything we do, we have to take safety into the consideration. The firemen, Charlottesville Fire Department gave us some fire hose and just wanted to see if it would track. We did wet it down a little, but just wanted to show you that what you work with, your fire hose, does conduct. So we're going to go ahead and make it hot and see what happens to the fire hose.
Pulling the water out of it.
So just to show you, the fire hose will conduct, and it is very hot. Woo! The next thing we're going to do, how many of y'all at home have an aluminum ladder? I've got one at home. Firemen, do y'all use aluminum ladders? Is y'all's ladder truck made out of aluminum? Okay. Aluminum, they're cheap and they do a good job, but our wires are made out of aluminum. All of our conductors are made out of aluminum. We want you to go away from here knowing you should never carry a ladder upright. And to y'all, the power lines are in the background. Y'all don't pay attention to them. Every year on our system, we have an average of 5 third-party contacts. Most of them deal with ladders, and most of them are fatalities. So if you ever carry a ladder upright, please look at the big picture. If there's any power lines involved, please carry it down low. Never set it up near power lines. In Alexandria District, we had a contractor put an aluminum ladder up beside a 3-story building. He had to reposition it. He lifted it up and it got away from him. And it went into our power line, the same voltage as this. And if you go there today in the sidewalk, you can still see his footprints where he was killed from getting that aluminum ladder into the power lines. And we'll just show you how good of a conductor an aluminum ladder can be. Just for the firemen, just to let them know, in Fairfax County, we just had a ladder truck that got into our transmission line. It tracked through the concrete into the firehouse and burned up everything in it. Luckily, the only person that got hurt was a piece of concrete flew up out of the ground and hit a guy. But luckily, there weren't any fatalities from electrocution during that. The next thing we're going to talk about are trees and limbs. A limb can lay on a power line, or a tree can lay on a power line, and it can just sit there and not do a thing if it's in high impedance to earth. But if you went up there with a chainsaw and cut that tree and it comes up off the stump, now the path is going to be through that tree, through the chainsaw, through you. One thing about electricity, you can't see it, you can't hear it, and you can't smell it. I can't look at that line and say if it's hot or not. What we have to do what's called tag, testing, and grounding that power line to earth before we can touch it. And we're just going to show you what would happen if a limb was up on a power line. Yeah. Right now, that limb is hot, and if it was laying across there and you went to take it off, you would get electrocuted. And we're going to show you now what would happen if we put it across two different potentials. So if you went to take it up off that line, that energy now would go through you to earth, and with 7,000 volts and the amperage rising up on that to around 680 amps, it would probably be a fatality. The next thing we're going to talk about are mylar balloons. All of y'all are some handsome guys, some of you. All of y'all give your wife mylar balloons at Valentine's Day and on their birthday. These balloons have become a real headache for us, and it's very dangerous for linemen to go up and take them off lines. They do track, and the linemen have to go up with a knife and cut them off. Recently in Central Division, we had a little girl had a birthday party. Her parents gave her a handful of mylar balloons, about 10 balloons. They got away from her, went up into power line, so what did the mother do? She put an aluminum ladder up on the pole to get the mylar balloons off. Fortunately, the string on the mylar balloons was not wet. She got a tingle and wanted to know why she got shocked and called us out there, and we explained to her why. But we have had mylar balloons knock whole circuits out on our system. So what we're going to do, we're going to bridge this cutout. And if you look at this light right here, you'll see that mylar balloon will track through and light this light up over here. See the light on? And just to show y'all, if you look right here on the balloon, you can see where the electrons were tracking through it. The next thing, I want to pick on the firemen a little bit. Do y'all pull meters if you go to a residential fire? All right. Just to let you know, if we have a 15 kVA transformer, which is a small transformer, and we have 4-aught wire feeding it, which is the standard, feeding a meter base, within 1/8 of a second, you can generate 6,000 amps of fault current. Unfortunately, about 15 years ago, I didn't pay attention and look behind the meter before I pulled it, and a meter exploded on me. I got glass all over me, little cuts. Fortunately, I didn't get electrocuted. But what we're going to show you now is this meter base, and this is going to pop and make a little noise right in this area, just to let you know. But something that generates up to 6,000 amps of fault current can make a big ball of fire. On this particular meter base, the way I have it rigged up, it's around 600 amps. It's not 6,000. But you'll see what happens if you had 600 amps of fault current. All right, we're going to go ahead and do the meter base. Fortunately, now we use plastic covers on the meter base. Before, we used glass and they would explode. But with the new plastic covers, they don't explode like they did in the past. The next scenario I want to talk about, and this, we have had fatalities on our system from this. The scenarios are if you're driving a dump truck and you raise your load and you get it up in a power line and you step out of that truck, you could die because you're touching a hot truck. On a vehicle, you have tires which are made out of what? Rubber, and rubber is an insulator. It could be a scenario, a fire truck, a ladder truck gets up in our line. It could be a crane up in our line. It could be a car hits a pole and the wire breaks and it's laying on a car. I'll tell you what happened in Fluvanna County. I live in Farmville near there. A lady hit a pole, broke the pole, the wire laid on the car. It was about 2 in the morning. State trooper pulls up and says, "This lady's hurt, she was bleeding." He went up to try and rescue her and tried to open the door. When he tried to open the door, he blew off these 3 fingers. because the car was energized. Like I said before, nobody looks at the big picture and realizes the potential that's in a power line. He was focused on one thing, helping that lady, and he ended up losing 3 fingers because of it. What I'd like for Mike to do now, go ahead and energize it. Right now, that cart is energized. Like I said before, you can't see it, you can't hear it, you can't smell it, but right now it's energized. And we're going to put a voltmeter on it just to see what kind of voltage we have on that cart. So that right now, if you walked up beside this cart, would you know it's energized? All right, we're going to show you, and if you see the little hippie man here, and look at that guy right there and tell, this is him from the 70s. See Mike right there? That's him from the 70s. And he's going to go up and try and help somebody that is in a car that has hit a pole and a wire's on it. And you'll see what happens. So before you rush into a situation, look it over real good. I'm going to tell you the harsh realities of what, I'm a trainer at Dominion, and I teach young linemen how to do their job. And one of the things I teach them is if you see somebody getting electrocuted and you don't have a stick that's tested or your rubber gloves on, you got to let them go. Because if you rush up there to try and help them, instead of losing one person, you're going to lose 2 people. So we tell them all that. And your gut instinct is to do what? Rush and help somebody. But you don't want 2 fatalities. So you have to realize electricity, you can't see it or hear it, and it's too late. Once you do hear it or see it, it's too late. Next thing, is this the kind of turnout gear y'all use, these boots? The firemen? Y'all have different. All right, but the boots you use now have a steel plate in them, right? Okay. What I've done, I put a hole in the bottom of that boot to that steel plate, and there is a phenomenon called step potential. What that means is a wire can lay on the ground and not do anything and be hot. A wire, if a wire's broke and it's hanging this high beside a pole, you would assume it's dead, but it's more than likely hot. Step potential is if a wire is laying on the ground and firemen are there soaking that area down and getting it real wet, right beside the wire, within a couple feet, is one potential. It's real high. As you move out, it gets lower in the earth. Well, if you walked up beside that wire and you had your feet apart and you were at 2 different potentials, one potential could go up one leg and down the other, and you could be killed. We teach our people, stay 30 feet away from the power lines until you've tagged, tested it, and grounded it to earth, and then you can go up and work on that power line. Until then, you cannot do it. So what we're going to show you now, if you had a hole in that boot, what could happen to you? All right, the next thing we're going to talk about is misutility. How many of y'all, guys that work for public works should know this, before you dig a hole, you have to call 811 misutility. I want to show y'all this shovel. You see this hole in the shovel? This is from a new employee we had who was digging an open underground, and he got it into the hot wire. And when he did, it put a hole in this shovel, and he took off running. And he said, I quit. I don't want to be at this company anymore. The lineman talked him into staying and said, you know, you have to be very careful digging around our lines. You have to dig away from where the marks are so you won't hit it and knock the dirt over onto it, off of it. Our sticks are tested at 100,000 volts per foot. This is a fiberglass shovel. With this fiberglass, does it look pretty clean? Pretty dirty, right? You think it would stop voltage? I'm gonna tell a story on myself. I used to work in the Outer Banks for Dominion, and I was digging a hole one time and I had my hand right here on the metal. And I hit the wire and another guy kicked me off of it because I was stuck on there. If he wouldn't have, I probably would have been electrocuted. Whenever you dig, make sure you're touching this part of the shovel, okay? When you're digging, you are on Earth. Electricity wants to get to Earth. That's the path it wants to take to Earth. So if you're down there digging and you're right standing on Earth, could you get electrocuted just digging a hole? We've had a lot of third-party contacts just digging a hole. What we're going to show you now is what would happen. How many of y'all have heard a loud boom and then the lights go out? Okay, that's what we're going to show you right now if you were digging a hole. This fuse right here is going to blow this way. If I was y'all, I would back out a little bit. It's going to be a little loud. What I would like for y'all to do is put your fingers in your ear because it's going to be pretty loud. If you decide not to put your fingers in your ears, do not complain to me that your ears are ringing, okay? But we're going to show you what would happen if a shovel got into a power line. All right. Let me just explain to y'all, that fuse right there was a 3-amp fuse. We have fuses on our system up to 200 amps. That was one of the smallest fuses we have on our system, right there. Usually when it blows, it's about 30 feet up. You don't feel the concussion. Any of y'all feel the concussion? It's down here low beside you. That's why a good lineman, if you're up there working on the pole like that and that blows right beside you, a good lineman always has an extra pair of underwear with him because he's probably going to need it when that happens right beside him. The next thing we're going to do is we're going to talk about critters that get on our system. Every year, a lot of squirrels sacrifice their life for us to have electricity. You know, squirrels have a long tail. They get up on top of a transformer. Their tail is still touching the tank, and then they get on the high voltage lead. Then you hear that loud noise again. Where I worked at in Farmville, we have had squirrels, possums, raccoons, black snakes. We've had bobcats. We've even had a bear climb up a pole. Our system works on what's called 60 cycles. So that means your power is off 120 times a second. We can't comprehend that, it's too fast, but that means everything we have vibrates a little bit because the power's on, then it's off. So the animals think it's vibrating, something's up there. I had another co-worker that a fuse blew. He climbed up the pole to fix it, and a black snake fell across his belt about 2 in the morning. You know, that'll pucker you up a little bit too. But every year, we just had a black snake, took a substation out and took 20,000 customers out just about a month ago. And what we've done, we put a snake up here. This fuse is going to blow this way, and it's going to be a little bit loud again. So y'all may want to cover your ears. Yeah. Did y'all have any idea that the fuses were this loud? Yeah. They will scare you. All right, the next thing I want to talk about is something very serious I want all of y'all to consider. 30 years ago when I started with the company, if I went to a subdivision and one phase was out in a subdivision and I went this street over here, the lights were out, I could say A phase is out. And I knew it was out because everybody's lights were out. Now if I go to a subdivision, every other house has lights on. And I can't tell what phase is out because everybody has generators now. Well, I told you at the beginning, a transformer is a very dumb device. It'll take high voltage and make low voltage, but if you plug a generator into your outlet and then into the generator and you don't turn your main on, it will backfeed through this transformer and create primary voltage. The last major event that I worked when I was still in the field was Hurricane Isabel. And I worked a little area called Cumberland County. And in that one county, we had 5 customers backfed onto our line. Now what that means is, during a major event, the wire could be on the ground for 2 weeks dead, and then somebody goes to the hardware store, starts a generator, now you got primary voltage right beside you. So when linemen hear generators, the hair on the back of their neck stands up. We tag tested ground the wire before we work on it. If we do that and they start a generator, it'll burn their generator up, and that's what we want to do, because it is against the law by the National Electric Code to backfeed onto our system. And what we're going to do here, we're just going to show you what kind of voltage we can get on our system with a generator. So we're getting about 8,000 volts with the generator. Out of the transformer, we were getting about 7,000 volts. So you have to be real cognizant. We don't consider anything dead until it's tag tested and grounded. And we have been out there and verified it. What we teach our employees, I want to get across to y'all, we teach them you should stay 30 feet away from any power line that's on the ground because of step potential. What I want to get across to y'all, if you're out there working a thunderstorm or a snowstorm or a hurricane, if there are down power lines, try and keep yourself safe first, then try and keep the public safe. Don't ever reach up and move a power line. We cannot go out and move a telephone line without testing it first. After we test it, we have to use our gloves and sleeves because we don't know what's happened 2 blocks away. That telephone wire may be wrapped up in our primary. And I know people go out and move wires all the time. I'm gonna tell you what, it's almost like playing Russian roulette. During a major event, you don't know if the cross arms are broke, sagging into wires or anything. We have had instances where the whole telephone system's energized at primary voltage or cable TV. So we just want to impart to y'all, please be safe around power lines. Don't get near them. Don't move them out the way. Wait till we get out there, tag, test, and ground it, and move it out the way for you. We don't want anybody getting hurt. We want to partner with the first responders and the public works and everybody to teach y'all about power line safety. So when you're doing your job, you won't get hurt. Every day y'all have somebody hits a pole or there's an accident around here, right? I mean, when you are a first responder and you're the first one out there, look at the big picture. Keep the power lines in mind before you rush into anything. Just like one of y'all, if you have a dump truck and raised it up in our load, if you step out of that dump truck, you're going to get electrocuted if it's still in our primary line. Just because somebody's gotten into our line does not mean the fuse is blown. We find hot power lines on the ground all the time. So that's the presentation. What did y'all think?